I put my money on the sun and solar energy. What a source of power, said Thomas Edison. Next building that you go into could be entirely powered by solar energy and you wouldn't know it. For example, the Newark building, Ohlone, is mostly powered by solar energy for most of its solar uses. Businesses, as a business student, I want to work with sustainable energy and I have found great interest in solar energy. Collecting solar energy seems like a simple task, but it has many parts to it. Today I will be telling you about what solar energy is, how it works, and how it turns into usable energy. One of the most abundant energy is solar energy. Earth gets around 173,000 terawatts of energy continuously from the sun. It can be captured through PV cells or mirrors that concentrate solar radiation and can be turned into usable energy. Today I'll be talking about PV cells because those are the most common type that we use, also known as solar panels. Solar energy is used in businesses, homes, and school. Like I said before, the Newark location has 38,000 feet of solar panels that provide 45% of campus electricity needs. And aside from that, there's also Walmart, Kohl's, Costco, and Apple who also uses solar energy as their main source of power. Now that you know a little bit more about solar energy, let me tell you how it is converted into usable energy. It involves physics, chemistry, and electrical engineering to bring it all together. Photons and light are equal to the frequency of the light. Photovoltaic effect is when a photon hit the photoelectrovoltaic surface. In the 2014 book of Applied Energy and Environmental Tech and Materials, the photovoltaic effect reflects to the semiconductor material to absorb light and generate electromotive and separating electron pairs to excited by electrons. According to Janelle Penny from Resilient Building, the amount of sunlight that hits the panels will determine how much energy it will produce and how much energy you can keep. When photons hit the surface, it excites the electron in the materials, and when enough electrons are excited, it will lead to an electric current. None of these will be possible without the use of semiconductors, which are materials that are neither insulators or conductors, they are right in between. The most common ones are silicon wafers, which are these ones. These can either be positively charged or negatively charged. They can both exist in the crystal structure, which are in PV panels. P-type lacks an electron, and N-type has an extra electron. In an ebook from 2016 by Joel Carter, the cell structure can be simplified as a P-N junction. When exposed to light, which is the combination of two layers of differently doped semiconductor materials. Now that you know about the components of how solar panels work, let me tell you how the sunlight is turned into usable energy. Solar panels are the combination of everything that I just talked about before. The thickness of the P and N layers are very important. The N layer, this is a P-N junction, sorry about that, and the P and the N layer is very important. The N layer is very thin and heavily doped. The P layer is very thick and lightly doped. This is so that light can penetrate through the top layer and go into the P-N junction. When light hits the cells, series reaction will happen, and with the help of certain items, we can turn them into usable energy. When light strikes the depletion zone, electron hole pairs are generated in a wider area because of the wider depletion zone. Electron hole pairs create when electrons are no longer paired to an atom. Electric field will then surround the depletion zone when there is enough electrons moving out of the holes. The N region is positive, and the P region is going to be a little bit negative. So the electrons are going to move to the positive side, and the holes are going to move to the negative side. And when you connect the load between the top and the bottom, that's when electrons are going to move from the top down to the bottom, and that's what generates electricity. Now that you know electron is collected in things called fingers and busbar, which are these ones, and these are then routed into other cells through copper wires. This then creates a direct current, and with the help of the inverter, it can be turned into AC power. which can be then stored in a battery. The angle and the amount of light will affect how much energy the solar panel will produce. According to the article from EN, Simulation of Solar Panel Control System in 2021 states that the solar panel works best when the solar beam falls perpendicular to the panel, when the sun falls perpendicular to the panel and is at a degree of 75 to 85 degrees. As the speech comes to an end, I would like to summarize the content of what I said today. Today, I'll let you know about the abundance of solar energy and how it is collected and turned into usable energy. Harvesting solar energy seems like a simple task, but it involves many science and engineering aspects. Solar energy is bound to be in our future. There is kind of an inevitability about it, said Jim Intel. Thank you.